Good evening. Now we will have a keynote, Low Carbon Concrete Pathways to Sustainable Construction. This keynote will be performed by the engineering Thais Fortes. She's a civil engineer, postgraduate in pathology of construction and concrete technology. She works in the area of decarbonization of concrete, and she's a technician of CSN Cement. Good evening. I would like to thank the invitation from Professor Teresa to be here with you in this good evening with a lot of techniques and science so that events like this happens. Congratulations for the organization. Today, the theme I bring is low carbon concrete, pathways to a sustainable construction. And I thank again for the opportunity. Quickly introduction, the company I'm a part of, CSN, we work in 6 main groups in the area of steel, mining, cement, logistics, energy, and innovation. It is a massive company that has more than 40,000 employees. And here we have some images that illustrate the operations of the CSN group. In our cement platform, we have an installed capacity of 17 million tons per year with 7 integrated plants, 6 grinding units, and 21 distributing centers. We also operate 6 aggregated plants and 4 ready-mix concretes, opening another one this month in Minas to supply the demand of P15 and another franchise channel in the retail segment. We have an expansion project with 3 new cement plants, one in Pará, one in Sergipe, and another one in Curitiba in the south. And those plants will add to the group plus another 8 million tons per year. We can see in this chart that the consumption of cement and steel has increased with time, but the increase of cement has increased tenfold in the last 65 years, while steel and wood, they ended up stagnating. This shows the importance to study the impact that cement causes in society because it's a very used material and it's important for the development of nations. Here we have a graph that shows the emissions per segment, the emissions of CO2 per segment, and it shows that the segment of cement is responsible for 7% of global emissions of CO2. Mainly, in this case, we're talking about CO2. And this matter of CO2 emission is inherent to the producing process of cement. For a very long time, the algae absorbed the CO2 from nature. It was deposited in the seabed. And over time, we created layers of limestone. And over time, the human being came and saw that limestone being calcinated, decarbonated, we were able to make cement. So the productive process of cement, we have a big part of emission of CO2 because of this carbonized material being emitted to the atmosphere again, and it's being returned. If you look at this chart, we see that 50% of the emitted CO2 comes from this CO2 that's being released and being thrown back to nature. This is very difficult because we have a limitation to reduce these emissions. We have to take attitudes to neutralize these emissions, seeing that nowadays we don't have any other material that has been produced in scale, in the same scale that the cement has, to supply the demand, the national demand and our planet's demand. Nowadays, we do not have another material that's scalable the same way the cement is. Nowadays, we're trying to neutralize the emissions that the chain of cement brings us. So data from ABCP shows that 2% of total emissions from Brazil are from the production of cement. And we have projections that there will be an increase, an even bigger increase, demand for building. Many people go to cities. We're developing cities. So there will be an even bigger demand for cement. Here I bring a chart that shows the density of CO2 emission per country. We can see that by territory, it's a little bit small to see. But here we have Vietnam with much more emission than Brazil, that has a bigger area, mostly because of their energy matrix, but also by the cement produced there and here. In Turkey, the same thing. It's a much smaller country, but with an emission rate much bigger than in Brazil. It's not because of that we are not going to do our part, but we are showing in the scenario that we are included. The cement and concrete are essential for a modern society, for the development of infrastructure, of roads, bridges, buildings, dams, tunnels. Cement and concrete are very important in the development of urbanizing and also in the industrial growing of Brazil and the world. And an important fact is that concrete is the second most consumed material in the world. It only loses to water. So divided by the amount of people, the amount of concrete that we use in the world is the second most consumed product, only losing to water. And looking at the composition of concrete, we can see that it's basically water, coarse aggregate, fine aggregate, and cement. And that 90% of the emissions of concrete come from cement. So the other 10% left are from the other activities connected to the obtaining of concrete, showing the importance of the cement in all of this chain. Knowing all that, the GCCA, a Global Cement and Concrete Association, created a roadmap in order to identify what actions we need to take yesterday, today, and for some time in order to neutralize the emissions of concrete and cement. Here we bring some examples that I'm going to talk about ahead on what actions we need to do to be able to neutralize these emissions that we are not able to reduce. We also bring some SDGs that are the Sustainable Development Goals that are related to this transition in the cement and concrete value chain, industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and product, and climate action. So we also brought the SDGs related to this transition in the supply chain of concrete. We also have in this pathway, we also have some niche demands in order to reach those goals. Demands that come from demand and also from the offer. In case I work in a cement company, I work with the offer. But people, companies, industries that will use this material also have a very important role. For example, the part of dimensioning of concrete per performance, not by use, but by analysis of material to the specific location where this concrete will be used, if it's going to be in a garage with direct carbonation. analyzing the concrete and testing it not by resistance but by strength, using tests, resistance to carbonation, resistance to electric density, and also absorption of water. In second place, the industrialization. If we work with buildings that are done on-site, we have a lot more possibility to have excessive use of material. We have more generation of waste. If we work with a more industrialized building, we tend to have less waste and emit less CO2 because everything will be well thought. On site of whoever is making, for example, a prefabricated, if you take the operation of the construction site, the need to make the concrete on site, it is also important for a more sustainable construction. The builders also have to think on that when before they even start the project, thinking what ways can I industrialize more my construction to be more sustainable. I think it was on the wrong slide, I'm sorry. Here I bring the industrialization. Here I talk about a little bit of the use of cement bag and bulk cement. When we use the bag, we mix the concrete on site. So we have a high use of cement, probably a lower durability because most of the times we don't measure anything, a lower mechanical strength, an increased production of concrete waste, low or no control. On site, we don't have as much control as in the industry. And then we have a higher emission of CO2 per structure. When we work in an industrialized environment with bulk cement, we are able to have lower cement consumption, increased durability, higher mechanical strength. We are able to mitigate waste. We have a full control of all the process because we automatize everything. We implement those processes in the industry. This way, we are able to lower CO2 emissions per structure. Regarding the supply niches, like the ones that I act, we also have some key points that companies need to see. For example, improvements in energy efficiency of their units. Old units need to be improved. New units, makes everything easier, but we have to improve old ones. A reduction of the clinker cement ratio, increase our proportion of supplementary cement materials, the use of low carbon fuel or the use of admixture to reduce water contents, and also the reduction of cement, and as well carbon capture, utilization, and storage, which is just capture CO2 from big polluting sources, purify them, store them, and then give a destination which could be storing or the use, which I'm going to talk ahead. So, talking about energy efficiency, we need an extensive revamp on those old plants and also decarbonize electricity. In Brazil, we don't have this problem. We have many, but that's not. Our energy matrix is very clean. The company that I work, all of the company that I work with the energy generated by their own dams. But that's not the case from other countries, which need to work on that point, the decarbonization of electricity. The use of supplementary cement materials, which was the slag from blast furnace, the use of fly ash, which could be a byproduct, but it's captured from coal plant units, the silica fume, which is captured from electro fumes, the natural pozzolans, which can also be calcinated, and also limestone filler, which could become a good aggregator to cement to improve some characteristics and also reduce emissions. And what are the advantages of using this? There are technical advantages because they will improve durability, workability, and performance of concrete in the final product. There are economical advantages because it reduces the consumption of energy and the cost of production through lower clinker content, and also to the environment because instead of consuming our raw material, we reduce the raw material putting another component that's already available, and that could be a problem, and to us it could be a solution. Here is an image that shows the composition of some of the types of cement supplied that are very common in Brazil. I will highlight the blast furnace, which is the CP340, which has in their composition from 35 to 75 slag. It could have from 25 to 65% of clinker. So you see the reduction that you can have in this type of cement, that if you use slag properly, and you could still have good cement to send it to your region, reducing significantly the CO2 amount, seeing that it comes mostly from clinker. The slag is amazing. I am a fan of blast furnace slag. It brings some benefits that cement wouldn't have if we don't use slag, but we have problems because siderurgy is improving their sustainability area. They're not using blast furnaces anymore. Most of those furnaces are being turned off, and they're buying electric arc furnaces where we don't collect slag. So the slag will, as years go by, we will have less available slag. Nowadays, it's not a problem to us, but it could be in the future. And fly ash will also be a problem because we won't have coal plants. In Brazil, we have other sources of energy. We have many buildings of wind power. So we have many things happening that will reduce the use of coal plants because they are not smart when we think about sustainability. So what happens in the Northeast? I used to work with fly ash, but it was very seasonal because they only turn on coal plants because when we don't have energy from other sources. So as time goes by, we end up having a reduction in the availability of these two raw materials that are important. So what do? We need to look for other materials. We need to look for other supplementary materials. So, for example, calcinated clay. If we find a good source of kaolitic, we can have a good source of this material. We can treat this material and use it with cement because it interacts with calcium hydroxide and it increases resistance and durability of concrete. This is not a material that will enter inert in the composition. It will enter and increase in durability and strength. Nowadays in Brazil, we don't work with this type of material, but there are other cement companies that work with this material, so that's an alternative. We usually work with substituting 15 to 30% of clink using calcinated clay. We also have limestone fill. Everyone that has a cement factory has limestone quarry, and if you work on the grains, we can have a much better result. Nowadays, there are many studies in the world that works in the granulometry of separated materials in order for us to get the thinnest material because they are different. If you put everything in the mill as it's done in Brazil, we don't extract the best grain. When I talk about clinker, limestone. So if we do separate grinding, there are many relevant studies in the theme, and it's very important so we can develop cement with more limestone filler without losing performance. This is what I made a comment. If we add limestone filler, we can do more. We are not going to aggregate problems to that cement, but solutions, because it will have less CO2. Another niche of the suppliers is the use of alternative fuels, the use of hydrogen. There are many problems in the company that I work about green hydrogen to work as fuel for many operations. So it's a very interesting theme. Working the substitution of fossil fuel, we use a lot of biomass in our company. We even have a company that only works collecting all of the residues from the market that could be interested, that has use to go in the oven. So instead of using a material that would be harmful to the environment, we use a material that would be a problem. This is everything well thought and researched, so we don't have problems in the final product. We also have CCUS, the capture of carbon, use and storage. The graph is very small, but here I show cost. The capturing of CO2 can be done directly from the air, which has the highest cost. And we also have other sources like that's nothing. We just capture CO2 from other sources who are polluting. This is still a process that is very demanding, and we see that these processes are working in other countries, but they have grants and governmental funding. So to apply this and to make it more feasible, we need the support of the government to help us to incorporate this sort of project, this in a pilot project, and then do this in large scale, which is an alternative. And through the roadmap, this represents 36 of our goal of reducing and neutralization of CO2. So this is a very important part of the process. If we don't invest in study, we will be left behind. I already went to some companies abroad, and we saw that the average is $70 to $100 per ton of CO2 captured. We need to capture, purify, storage, and then distribute. So there is a whole process to do that. So nowadays, we don't have any project ongoing because of this high cost and this lack of incentive from the government up to now. Here I bring some examples of the use of CO2 capturing. There are many applications. Our applications would be here in the area of instruments that we can use. Treatment of material, incorporation in concrete, which is the case of carbon cure. Carbon cure is a patent Canadian technology where we inject CO2 inside the concrete truck. What happens with the CO2? When we have the hydration reactions in cement, we have the incorporation of this material as calcium carbonate in the cement matrix, which will make this matrix more dense. It would increase in strength and durability and reduce the use of cement, the amount of cement. So we use less cement and have the same durability, bringing benefits in the reduction of CO2 to the concrete. So this is a project that we will start a pilot this year using CO2. But in this case, we will buy CO2 and we will incorporate into concrete. We won't do the whole process. We won't do the capture, purification, processing, and distribution. We will buy first, and then we will start this work reducing the load of cement in the operations of concrete. Here I bring some startups, some KO-ups that are focusing in this part of reducing the carbon footprint of concrete. Some in very early stages, others with high investments, and they are working hard, like Consolidated, Forteira, the Carbon Cure, Terra CO2. So these are companies that are studying and taking to many other countries, and they're also having contracts with some companies so that they help this reduction of the CO2 footprint in the cement and concrete industry. Looking at detail, Carbon Cure uses CO2 mixed in the concrete. Carbon Limits uses an activator to increase the carbonation of concrete. There is Neurostark, which is Swedish, that also uses this material to carbonate. The Carbicrate that uses the cure of blocks with they cure blocks with CO2 in industrial residues, and also Carbon Built that also cures blocks with CO2 chambers. In the case of Carbon Limits, this increment in carbonation for the concrete, it might not always be good. So if we increase the depth of carbonizing, we could stop armoring. But if we are working on pavement which has deep, so we can work in the addition like Carbon Limits in pavement, so where we don't have this problem in carbonation. There is also Forteira. Forteira is a company that I visited in San Jose in California, and they treat fill limestone in CO2, and they transform this material from inert to material, and it becomes an addition to cement. And it is being studied in one of the norms in the United States, C12525, to become an SCM. Why? Because it has reactivity. So this material is being studied. It's a patent that treats this fill limestone. It is a widely available material treated with CO2, and it transformed the mineralogy of the material. The natural carbonation also needs to be measured because our structure elements are being carbonized over time. So why don't we measure the rates of fixation of carbon in our structures that are apparent? When we make the outside part of a building of 25 floors, we have rules in civil construction. We need to wait 14 days of cure. In 14 days, this part is already carbonating. What's that amount? What's being fixated in this part? We still need to account for that and put it into the math. This is important. We also need to amount for the whole production in the chain, even for the material that it's applied. And the CSN has its own goals that's important for steel, for cement, and for mining. So we have the goal of reducing 23% per ton of cement by 2030, and a reduction in the clinker factor in cement by 16%. We also have a goal from mining and siderurgy. In cement, we are using alternate fuels and biomass. There is a reduction in clean factor in cement. We have operational efficiency and works with CCUS as in carbon cure. The product we have today that it's well aligned with a more sustainable world is the EcoCem 50, which is a high-performance cement. If we compare it to a normal cement, it has 40 or 50 less emissions, and it also has performance. So in this graph that I bring, we are working FCCAS of concrete, so resistance characteristic of the concrete in 28 days. We compared the two cements from our own companies. One is IRS, which is a very common cement, and we used EcoCen 50, which is this proposition of ours. So we can see that for the same FCK 35 for IRS, I have a more consumption, and this in CO2 emission is very impactful. You can see that the same FCK for EcoCem 50, we have the emission of 101 kilograms per cubic meter of concrete against 146 kilos per cubic meter of concrete, showing just change in cement without loss of quality and resistance. On what's important, we can reduce the emissions. Of course, there are limits depending on the type of building. So this cement might not give you the same quickness than in an industry of prefabricated. All of this needs to be taught in engineering. We are here to think on good solutions, and EcoCem 50 is a very good solution for concrete companies. Bring with them this green flag of reduction of emissions without losing quality. We are also emitting EPDs, which will bring data regarding emissions of all our products, data that is validated. It's not data that we want to show, it's validated data that it's validated by international organs, agencies, because we need to measure where we are so we can see where we can improve our products. On top of that, we also need the support of government legislations and that support this type of business and the evolution of the supply chain, because we know the price is king. For example, when you buy concrete for a construction, if we have laws that help us, we will move forward much faster. So the solutions of low carbon will need to compete economically with traditional concrete. So regulations and agencies have an important role in going towards to less emissions and less impact. And this is what I prepared for you. Thank you all very, very much. And I am available for questions, doubts, comments. Thank you very much. Questions? Good evening. I would like to make an observation and a question. First, I think we need to get used when we talk about sustainability involving the industrialization of civil construction. We need to think on the social on a country like ours with the unskilled labor. So I'm very bothered that the industrialization of civil construction is a sustainable construction. Maybe in our country it isn't, because looking at the social point, so I always make this addendum because it is very important. Our civil construction, the labor is unskilled, most of it, and we need to worry about that. It is the path of the future, but we need to worry about that. Regarding to that point, we are facing many problems with labor, because the age range of the labor force in Brazil is increasing because the son of the builder is not becoming another one. The person that doesn't have any technical study, they won't be working in construction anymore. Now we have a government that supports a lot, so people will get minimum wage in a construction and they can stay at home. We have a lot of problems in the constructions. I am from Rio. We have huge problems with the lack of labor and the lack of commitment from people. Because a person that misses and you leave your station with no one, well, we could develop people who want to work and include them in the process. This is very welcome. But there are parts of the process, in the construction process, that we have problems with. And as construction is the cheapest, industrialization comes after. We don't have a lot of machines in the construction. There are a lot of people. But as time goes on, we need more machines because of this lack of labor. In some places, in big cities, I agree with you. But that's not the reality of Brazil. We need to be aware of that. And we also need to worry about the education of these people. It's not only because they can't do it. We need to worry. It's an addendum that I do as an educator, something that we have to think about. Second question. In Switzerland, in many places, the research is using concrete residue has been very promising. The project she showed yesterday, heating it to 600 degrees, you can easily recover the dehydration of the concrete. With a carbonation like Switzerland does, you get a lot of gains, and I don't see any big company in Brazil having this as a project. I would like to see your view on that. I understand that companies nowadays has a lot of ambition. In the United States, 1 ton of slug is $170 to $200. Here we buy it very cheap. We don't have a problem in this lack of product, so we still have a lot. So the companies still haven't tried harder in this point, like you said, that Switzerland is way ahead, Europe is way ahead. Most of it is due to the public policies implemented there. Like Holcim is a company that I started as an intern, is a Swiss company that has a completely different vision than the one that we have here. They incentivize the technical development of cement that's very different, like the public policies. They already charge for exceeding emissions of CO2. So with this regulation that's coming, we could get faster gains in the industry that will try their best so they don't lose money. More questions? Good evening. I forgot your name, sorry. Thais. First of all, congratulations on your presentation. It was fantastic. An idea came to me. You said the term durability. From the point of view of structural designer, the durability is associated to the porousness of concrete. Depending on the harm of environment where it will be inserted, it needs a covering for this structure. The higher the class, the higher will be this covering. This cover is directly associated with the porousness of the concrete. I was thinking it would be interesting that we, for example, in order to reach a specific durability, to propose a less porous concrete. I don't know how we would work the cement in order to propose a reduction in this covering, so we would reduce the volume of concrete, and that would be a more sustainable way of thinking. What do you think? When I comment about working the concrete, not by normative standards that are established, but by tests that show what is the smallest length that the cement needs, where it will be placed, and with real tests, not just expect tests and minimum consumption, which is in the regulation nowadays. Because we can use a less consumption nowadays, and we will have the same consumption. Why not predict the valuing and evaluation of performance, and not that's all related to sustainability? Verify what's the capability of that concrete, what it needs for that location it will be inserted, so all is aligned with the theme. Do you work with designs? Yes, perfect. I love to get to meet designers. We want to understand what you guys think, because it's important to be side by side. Most of the times, the project come to us in Rio asking for a 36 gigapascals, knowing that in Rio our aggregate is very bad, so the designer needs to be very well aligned in the place where it is. That's why it's important to be close to you. Just a comment, for example. In my point of view, I think as a designer, I don't understand most of the material part, but I know that reducing porosity, it would increase the durability. It would be impossible to work with the cement to reduce the porosity of the cement. A better adjust of grains of the material. With finer material, we can reduce the porous, which is the porosity we're talking about, this permeability that you might have in the concrete. You might reduce and improve the adjust of the grains of the mix of concrete, which will be together the cement that you're using, the fine and gross aggregators. In this better composition will bring you a cement less permeable. So it will be super viable, thinking in porosity, thinking about the reduction of covering and the reduction of volume in the building. Yes, the increase in the performance of concrete, the increase of resistance, durability, and then move toward a less volume of concrete, supplying the same structure. Thank you for your view. Any other question? Good evening. I was very well represented in the question of the professor. I would also like to bring another point of view. When we talk about sustainability in Brazil, the social dimension is what comes to mind. In this way, it's not about your presentation, but about a company. I would like to know if CSN has like a line of financing to support research, if there is any line in this sense. CSN is a very big company, and it also works close to all of the community around its operations. As I said, it's around 40,000 people, employees in the company, and there are many operations. I am a part of a small part of the company, which is cement, so I don't know all, but I know that in the areas that I act, Vitória, the CSN has worked with community, the development of the communities that are around their operations, which is very important for the communities and the company. All of the cement companies that I work at, I am on my fourth. All of them have always done social working around the communities in order to develop them and bring benefits to the whole region. But investment, for example, in partnerships, public-private, in order to do research, because I saw in your presentation you are interested in that, reduce carbon, improve the relation in materials inside cement, but I still insist. Is the CSA also thinks, which is very common abroad, to have companies with the university, the research sector, to develop better material? Yeah, we do. In the area of cement, we are seeing the possibility to work with the University of São Paulo. That's very interesting. In mining, we also have zero waste, which is a project that is in the process of hiring. We are hiring companies that are related to the university to start a project in zero waste, in using all of the material in mining waste to use in some way, like geopolymers. So there are many projects in many areas of the company. Any other questions? No? I would just like to take the opportunity, Thais, mostly related to what Professor Rodolfo said about high-resistant concrete. I have been studying this concrete, and it has as a negative point the high consumption of cement, which by cubic meters has a high emission of CO2. But as you said, it's very interesting thinking about global. So when you have a concrete that's more resistance using less water, we have smaller sections. This impacts in the weight of the structure of the foundation, and we are seeing in current research that it could have less emissions of CO2 on a global level. So this view of on a global level is changing, and people are more worried with that, thinking about more materials. I would like to know what you think about this type of research. I think it's very important, and it is very important developing technical development of concrete in this part of structure, on how we can better arrange the materials being used, because in this way you can reduce the consumption of cement. And then you can also measure what's important. The tests of durability are also very important, but it's what you said. We cannot compare a construction using different concretes in one that would be CFK 80. The structural concept will be different. The consumption of concrete in this case would be different. So we have to see global. And we also have to think on the durability of the structure. So increase the lifespan of structures. Predict this lifespan of the structure is very important. Thank you very much. Any questions? No? I would like to thank you. This is a token in name of the organizing committee. Thank you for being here. And with that, we end the keynote. Tomorrow we have more activities. Thank you very much. And if possible, I would ask each and every one of you to answer the survey from our event in the QR code behind the badge.